Hello, I am back. I listened to some of that recording, and you all knew this, but I did not know this. There was really bad audio. I was hearing it perfectly fine, but I'm using SoundHack to go from openFrameworks to this screen capture software called OBS, and the part you were hearing sounded much different than mine. It kept dropping in and out. Soundflower works fairly well sometimes, but it is not perfect, and I simply restarted the computer. I'm not sure how to fix SoundHack any other way. And that seemed to work. I have fewer applications open now, so hopefully this will go a bit more smoothly. I did mess around with the parameters a little bit. I made the highest Y points lower because I kept dropping my hand out by going too high on accident. So to prevent that, I just made the highest point a little lower for the data coming in. What else is new? So if you, in your code, in your app.cpp, at the end of this if statement, so if there are two hands present, do all these things, get all these data, and put that data where it needs to be. However, if there aren't two hands present, the amplitude value, the amplitude slider, will decrease linearly. So what I have here is a very simple way to do that. Amplitude equals whichever is bigger, amplitude minus 0.01 or 0. So this will decrease by 0.01 every frame, unless 0 is bigger, so it won't go past 0. So that's a very concise way to write a linear decay. So that way, when your hand comes out, it will silence the synth, but not immediately and awkwardly. It'll take a moment to do so, and that's an easy way to do that. And the reason we're not getting pops and clicks is because amplitude is determining the static amplitude of the grain. So we're not changing amplitude suddenly within the audio thread. Okay, so one thing I'm noticing with this synth, I have replaced one sound just because I wasn't getting anything interesting from the original sound. I did put a suspended cymbal rule in there instead. One thing I'm noticing is that when you're moving your left hand through these sound files, you can't get to the bottom left of these sound files. Your hand will just drop out. And I think I'm just going to accept that as a limitation of the synth. However, earlier I mentioned that you could devise a way to make sure your left hand is always your left hand and your right hand is always your right hand. And I thought that wouldn't be necessary. We can just put our hands over the leap motion in a specific order, and that will be fine. However, playing around with this for a while, just a short while really, I noticed that we will in fact have to do this. If one hand drops out, the hand that's left will automatically be the left, the way we have it now. And that just happens far too often, and it's not performance ready in my opinion in that case. Okay, so let's go ahead and run the synth real quick. Hopefully you'll hear it correctly this time. I should set amplitude to 0 when it starts. I'll do that after we play around a little bit this time. So right now I'll put my left hand in, and I'll start my right hand at the bottom so it's a little quieter. There we go. And then I can raise my right hand. Bring it in and out. But I noticed I made the left hand, it doesn't need to be as high to reach the top anymore. So see, I just dropped one hand out on accident. Happened again. Okay, so one idea I have, we need to run a check, make sure the left hand's controlling the left hand's parameters and the right hand's controlling the right hand's parameters. And using only the data we're given from the library, we need to determine if the hand is left or right. So I've put my right hand out here. I noticed two ways we could do this. One, I think will be easier. We know this is a right hand because the thumb is on the inside, and the library knows which one my thumb is. So if I put my hand reverse, now it would be a left hand. And the method I want to do is assuming my palm will never be up, my palm will always be facing down. That means the tip of my thumb will always have a smaller x value than the tip of my ring finger, which I'm trying to wiggle. There we go. So if the thumb is smaller, has a smaller x value than the ring finger, it's a right hand. And I think we can just use that information. Otherwise, if you're doing an application that's not this, because we don't need our palm up for anything. If you're, for some reason, using a leap motion and you need to have your palm up, I recommend, notice the midpoint, the blue circle with the yellow vector, the normalized vector. You could use that, make sure it's pointing down, and then do the same thing. And you could devise a way, so if the palm's up, then if it's a right hand, the pinky will have a smaller x value. If the palm's down, the thumb will have a smaller value. But I don't need the palm up, so I don't need to worry about that kind of thing. So I can just compare x values and react accordingly. So let's back out of the synth here and figure this out. Okay, so this is where the values are fed. Okay, so let's make an integer called left. So if, and we'll make a statement, if the hand at 0, the first hand as registered, x value, oh, not the hand position, my mistake, dot fingers at finger type 0 or 0 1 2 3 4 the pinky dot tip dot x. So if the tip of the pinky of this hand is at a smaller x value than the thumb, which is 0, in this case, left equals 0. If that's not true, actually, let's call this hand, sorry. Hand equals 0. Okay, I might be doing this inefficiently at first, but I guess it's good to watch. We can do this, put this here. No, we don't need to do that. I'm switching this back to left. I'm just going to keep moving forward, and then I might figure out a better way halfway through. That's usually what happens. So I'm just going to call this left. Left equals 0. Okay. And if this is not true, that means left equals 1. So this determines if that's a left hand or a right hand. So now we need a way. I mean, we could write the exact. I mean, that seems a little. It's a little obnoxious. I'm going to do it this way until I think of something better. We can do the same thing. I'm missing something obvious, and I'm aware of this fact, but this will work. Right equals 0 if hands. Oh wait. Okay, so if the pinky has a greater x value than x, then right equals 0. And then if that's not true, right equals 1. So simple hands right okay. So I think this is going to work. I can't wait to not be, screen capturing and find out the obvious thing I'm missing here. But let's go ahead and give that a shot. All right, I'm going to put my hands in out of order. Okay, that was wrong. Left hand, right hand. Okay, now if I put my right hand in first, then my left hand, it's wrong. Okay. That didn't work at all. What am I missing here? Simple hands. If the 0th hand, if the pinky X is greater than X, then that means it's the right hand. If the pinky's further right than the thumb, it's a right hand. And this is testing hand 0. So that seems correct to me. Strange. Huh. Oh, okay. Okay, so I think it was working. I did not adjust all of these. All right, so I need to do this here. All right, so distance 1 is the left hand. So this needs to be left. Left. And then same thing with this one. This needs to be right. Alright, I'm going to pull my right hand out. I'm going to put my right hand back in. Still works. I'm going to pull my left hand out. Then I'll put my left hand back in. And it's still the left hand. Okay, we have success. So, although I probably used more lines of code than was absolutely necessary, probably used a little extra RAM, this is successfully keeping my left hand with the task of the left hand, my right hand with the task of the right hand. This is assuming, of course, that it's one person with two hands, with a left and a right hand, and not a third person throwing a hand in. So this will work for one person with a left and right hand, which is meeting our requirements. Okay, so let's make a couple improvements to the synth. The emission rate is just absurd. It's really hard to get the emission rate down to like 1. So emission rate is similar to frequency, or actually you could very easily argue that it's the exact same thing as frequency. We need to curve that information. It's not acceptable the way we have it. So where is emission rate here? Okay. So what we need to do, the way I always curve frequency, and adjust the mic here, the way I always curve frequency is just to make a value for octave and take 2 to the octave power. So the octave will be linear, but the what we get from that power function will be nonlinear in the way we want it. So float temp octave equals this. But instead of going 0.1 to 1,000, we want to go, let's say, so 2 to the 0th is 1. Let's go 0 or negative 2. So that'll give us 0.2 or 4 grains per second. To 256 is plenty. Let's do 16, 32, 64, 128. Let's go to the 8th power. That seems like a reasonable range. And we'll still clamp that. Let's see, what is... I'm out of my mind. 2 to the 8th is 256. Okay, so the emission rate will be the power of 2 to the temp octave. All right, and that'll be 256. That's plenty high emission rate. We don't need to go higher than that, I don't think, especially since we only have 64 grains. So even if we have relatively short grains, we're going to fill our polyphony capacity. So let's slide up to our emission here. Let's do 256. And 2 to the negative 2 is 0.25. So we're going to have very sparse grains. Let's give this a shot. All right, so look at emission rate, which is the top. I can maybe mouse while leaping. There we go. The top slider value. It's hard. Okay. It's hard to get above 5 now, but we have a lot more granularity in this low region, but we need to get a little higher than what we have here. Okay. Strange. I'm not quite sure why 2 to the 8th is 250. Am I crazy? That's right. 8-bit. Where is this? Temp octave. I guess we can just raise this to be higher. I mean, I guess, or we could lower this. Let's do that. That's reasonable. So let's get that duration down, which is another thing we'll have to curve. But duration's down, volume's up, fingers are closed. Yeah, great. So now we have it's like a proper granular synth here. right, so duration is on the z-axis of the right hand. So max is 200, and if I go forward, I'm likely to lose my hand, especially if I'm at a low volume. So let's curve that as well. So we want the range of, see, let's do like 32 to 256 as well, I suppose. And we'll do this. We'll curve that the same way. All right, we can just use the same temp octave, overwrite it. Temp octave equals this. So 32 is 2 to the 6th, I believe. Oh wait, 8. Oh my gosh, 8-bit is 100. Well, let's keep moving. 8. I think that'll be good duration. You just power 2 to the temp octave. Yeah, we need to go lower. Let's go. You know, duration, it can go really low. Let's do, I mean, 16. It gets interesting when it's low. We can actually go much lower. Let's go. We could 2 milliseconds grain. 2 millisecond grains are interesting, in my opinion. So let's do that. All right, so if I'm right in the center, I have 14 millisecond grains. If I reach forward, I can get really tiny grains. So let's get that emission rate up. There we go. It's got the nice reverb. Or not nice reverb, but existing reverb. And left hand does the reverb, so let's turn that down a bit. So you see that I keep losing my hands, but it's not really destroying the values, so that's nice. Cool. And I think one thing I'm going to do, just immediately, that reverb is bad. It's, you know, it's not terrible for the first 30 seconds, but you know, it's just it's really has these resonant regions, which is just a standard problem with that reverb. Let's go to where I instantiate the reverb and just change the default settings here. So equals new reverb. Hopefully it gives me my list. It will eventually. I notice Xcode's usually a lot slower on these kinds of things. I don't know if it's because I use the same computer on this. I mean, the computer's expensive, but it's not good. That's the classic, that's the Apple motto, I believe. Reverb. Okay, and the constructor has, yeah, tell me more about this. Okay, so I know the first value is the absorption coefficient, so let's do 0.0. Let's do 0.1. That'll be a short reverb. And we can, hopefully, probably by now someone's commented on why jump to definition only works sometimes. Also, let's lower the absorption frequency. That's one part of the problem. We're getting this high resonance. I'm just going to copy and paste this since my IDE doesn't want to integrate my development in any way. Okay, so absorption we've raised substantially. The absorption frequency, let's put at 2,000. What was I thinking with 5,000, honestly? And the mix, oh, the mix should be 100% reverb because I'm blending that at the end. And pre-delay. That's a pre-delay is a little tricky. In this case, do we want pre-delay with a grain? I would say yes. But we have 2 millisecond grain at 40 millisecond pre-delay is, you know, a long time after that grain comparatively. So it's interesting. I think I'll leave it at 40. And that'll be fine. Okay, so hopefully that reverb's just a little less present, a little less obnoxious. Adding a convolution reverb to the library is on the agenda. It's higher than a few things, but it's also tricky. So once I get it, I'll add that. But I do intend on having a good sounding convolution reverb. They are expensive, but one thing that's missing from a lot of algorithmic pieces like that involve Xcode or involve C++ or involve Max even is the crap reverb. There's always bad reverb. Well, not always. You could always use a VST add-on and bring in a VST. It'd be nice just to have somebody giving away a good reverb unit. So hopefully I will be able to do that. So wish me luck. All right, when this synth starts, let's just set this amplitude to 0 until we tell it to make sound. So when it starts, it won't have that little pop at the beginning. All right, no pop. Reverb substantially less present. Interesting. So I feel like I have a lot more control over what's happening. One thing I'll note that I don't like, when I was mousing these things at the slider, well, I wonder if I can do that. I can now, yeah. Left open and right open, I could keep exactly at 0, and that has a substantially, I can't keep that up now. It has a stark effect compared to even 0.0, I can talk with my hands now, 0.001. And I need that. I want that in the synth. I'd like to be able to turn off the randomness for those parameters if I want to. So I noticed, watch, I don't have a webcam enabled, but watch, I'll open, close, and when my thumb and my index finger are actually touching, sometimes it works, like right here, but if I rotate my hand, you can see that my thumb and index finger, they are touching it in real life. They are not looking that way on the display. So something within the leap motion itself causes it to get warped like that. Let's test the other fingers. Middle finger seems to be doing a better job, actually. When I rotate my hand, And I guess I don't need to rotate my hand. I could just avoid that. But I like to keep my palm facing the device. I don't know why. I guess it doesn't matter. But yeah, I guess a quick fix. It looks like my middle finger is doing a much better job at actually getting close and staying close when I move my hand. So that's an easy fix. We can just change the index finger, which is index 1, to the middle finger, which is index 2. Funny using the word index in this case, but here we go. Finger type. So this is this nasty business. Finger type 2. And we'll see if that makes it easier to completely, quote unquote, close the hand. Not a whole lot. I mean, I feel like it's getting a lot closer. My right hand's doing a good job right now. Left hand is not. See, they're very close to closed, but they are not closed. So one thing I can do is really just change that minimum value so it's easier. They just have to be relatively close to be closed. See, when I'm up here, my right hand doesn't want to cooperate at all. See, my middle finger and my thumb are touching in real life. They are nowhere near that in the Leap Motion's field of view, I guess. That is not going to work. First, let's just try to raise the value, the distance. So we do 25 to 0 to 1. So let's just do 75. Make this substantially higher. So 75, the distance in the arbitrary units, is now going to be 0. All right, I'll raise my hands. Yeah, it works pretty well. Okay, I'm fairly satisfied with that result. It breaks down when my hands are further away from the device, but it does work in the highest range. I might raise it even higher because really getting the periodicity, the synchronicity to be exact, like it is right now, I think that's an important thing to be able to do, and to be able to get consistent pitch, duration, amplitude by closing the right hand is important as well. So you can do these kinds of things. Let's go ahead and hide the display. So this is what the audience will see, except they'll be real hands. right, so it's become something close to a performance instrument. The rest of this process will be deciding on values, changing values a little bit, almost definitely changing sound files. This is not a solo instrument, or at least for this use, will not be a solo instrument. So it's meant to provide gestures, some textures, and some other sonic interest. It's not meant to stand alone. So I think with that in mind, it will become, after a little manipulation, a useful instrument in that case. So I think this is the second time I've closed out this project. It's not done. I will push this code onto GitHub, so you can just download and play with it. Let's see. I'm going to add one more statement so that if you don't have a leap motion, it won't change your experience with this. So where's my leap motion stuff? Boolean use leap. All right. And I'm going to set that to true for mine. So in the setup, true. And in this statement, before we even count the hands, we can do if use leap. And all of the leap stuff we've been doing, we can tuck in that function. So that way, if you turn the leap off, which I'm going to make key command L, where else if key equals L for leap, use leap equals opposite of use leap. So you can turn the leap off. Let's make sure that works. All right, so it should be using the leap. Seems to be. If I hit L, the leap has nothing to do with it anymore. And it will still run. It won't crash if the leap's not there. And you can just, yeah, turn the amplitude up, play around with the, oh, I guess we can move the 3D scene, which isn't totally helpful for us. Yeah, but still play with the synth. I believe I provided a MIDI example that comes with ofxATK. And I am fairly certain that I showed how to attach the MIDI values to the GUI values. So it will be fairly straightforward. If you're watching this, you don't have a leap, but you want to control it with something other than your mouse, to attach MIDI controllers like sliders or knobs to this and control this in a meaningful way. So I hope this has been informative. I hope watching me fail over and over has raised your spirits to know that it's not just you, it happens all the time. Probably more to me than anyone else, I would assume. So I hope it's been informative. I hope it's been a good experience. I will do at least one more of these. Stay tuned. Thank you.